So hello and greetings. This is Dr. V.C. Sontake and I am going to teach the course Heat Transfer. Following is the objective of today's session. In this session, I will be discussing different modes of heat transfer. So, modes of heat transfer. There are three different modes of heat transfer by which heat can transfer from one part of the system to another part or between two different systems if temperature gradient is existing between them. And these three modes of heat transfer are conduction, convection, and radiation. Now, however, these are three different modes of heat transfer. There are some common factors among these three modes of heat transfer, and there are obviously differences as well. That is why there are three different modes of heat. So let us talk about first what are the common factors between these three modes of heat transfer. So the very first common factor between these three modes of heat transfer, that is conduction, convection and radiation, is temperature difference must exist between two different systems in order to heat transfer to take place by either conduction, convection or radiation. So the first common factor is temperature difference must exist. The second common factor is that while heat is being transferred from one body to another by either mode of the heat transfer, that heat transfer will take place in the direction of decreasing temperature. And from the law of thermodynamics, heat transfer will always be taking place from body at a higher temperature to body at a lower temperature. So these are the two common factors in these three modes of heat transfer. Now what is the difference? The difference between all these three modes of heat transfer is lying in the physical mechanism by which heat is transferred either by conduction, convection or radiation. Also, the rate of heat transfer in each mode of heat transfer is governed by different parameters. And when these parameters are grouped into mathematical form, they form mathematical equation, and that equation is known as law of heat transfer. So, the first very difference between all these three modes of heat transfer is the physical mechanism, and second one, the laws governing them will also be different. Now, in order to understand the modes of heat transfer, let us take one interesting example from daily life. Let us say there are 6 football players standing in a row, and there is a football on the left hand side. Let us consider this football corresponds to amount of heat, and the football players from 1 to 6 correspond to medium particles, molecules. Now my aim is to transfer this football from this side to the player 6. Or I can also say I want to transfer heat from left hand side to the player standing on the farthest end on the right hand side. That is player 6. Now there can be three methods or three modes by which I can transfer this football to the sixth player. The very first method is the football first will be given to player 1. Player 1 will give away this football to player 2. Player 2 will give or transfer this football to player 3, 3 to 4, 4 to 5, and finally football will be reaching to player 6. This is first mode. In second mode, football will be transferred to player 1. Now this player 1, instead of transferring this football to its neighbor player 2, will himself move away, will walk along to the player 6 and will give this football to player 6. And this way, football will be transferred. This is mode 2. And the last mode is, instead of giving football to either of the player, the football will be directly thrown to the player 6. This is method 3. So in mode 3 or method 3, no player is required to transfer the football, or no molecule or medium is required. Okay. So the mode 1 of transferring football oblique heat corresponds to conduction mode of heat transfer. Mode 2 of transferring football corresponds to convection mode of heat transfer, and mode 3 of transferring football corresponds to radiation mode of heat transfer. So this way you can understand. Now what we did in method 1, football has been transferred to player 1, to the nearest player, to the football. This football player has given this football to its neighbor player. This player 2 has given this football to its neighbor player 3. This process went on, and in this way football and hence heat has been transferred to player 6, from player 1 to player 6. So here the player or molecule 1, without moving from its place, has given the heat to its nearest molecule, and that process continued till the football or heat reached to the farthest player or molecule. In second mode, heat has been transferred to the player, football has been transferred to the player near to the football, or heat has been transferred to the molecule near to the heat source. This molecule will move away and will come into contact with the farthest molecule and give away the amount of heat to it. So in second mode of heat transfer, the particle or medium is moving, and in third mode of heat transfer, no medium is required at all to transfer the heat from one end to another. So this is the crux of all the physical mechanisms of each mode of heat transfer. This is a crude analogy between transferring of football from one player to another with the transfer of heat from one end to another. Now let us discuss each mode of heat transfer in great detail. So very first mode of heat transfer is conduction. So conduction is that mode of heat transfer by which Heat transfer takes place from more energetic particles, oblique molecules, oblique atoms of substance to the adjacent less energetic particle or molecule. And this transfer of energy takes place due to direct molecular communication or physical contact or interaction between the particles without appreciable movement of molecules. So in conduction, what happens? The molecules which are in contact with each other or they are in molecular communication with each other, one of the molecule will be at higher energy level, another will be at lower energy level. So heat transfer will take place from molecules at higher energy level to molecule at lower energy level. And during this process, none of the molecule will be moving from its mean position. It will only vibrating about its mean position. Now, medium in which heat transfer takes place by conduction are predominantly in solids, liquid and gases. However, the percentage of heat transfer by conduction in liquids and gases is less. So heat transfer by conduction takes place predominantly in solids. Now let us discuss the physical mechanism. So in gases and liquids, heat transfer by conduction is due to collision and diffusion of the molecules during their random motion. Now what happens actually in gases and liquids? The molecules are loosely packed. They are free to move here and there. So while moving here and there, high energy particle collides with the less energy particle, comes into contact and transfers the heat to the less energy particle. So collision and diffusion. However, in solids, the heat transfer by conduction is due to combination of vibration of the molecules in a lattice and the energy transfer by free electrons. So either of the mechanism may take place in solids. If the solid is particularly metal, the heat transfer takes place due to movement of free electrons and it is called as electron drift. And electron drift is the predominant mechanism by which heat transfer takes place from one end of the metal to another end by conduction. And if solids are other than metals, the physical mechanism of heat transfer by conduction is by molecular vibrations. Molecules vibrate about their mean position, and since they are closely packed in solids, while vibrating, they come into contact with the neighbor particles. If temperature gradient exists between these two particles, heat transfer takes place. Solid medium through which heat transfer takes place does not move during heat transfer. This is a very important aspect of conduction. In conduction, if a heat transfer is taking place through solid medium, that solid medium does not move at all. For example, if you heat a solid iron plate, it is not going to move during the heating. Have you observed if you heat any plate or any solid object, whether it starts moving during heat transfer? No. That is why when heat transfer takes place by conduction in solid medium, the medium does not move at all. and velocity of medium through which conduction takes place is zero or negligible. For example, if heat is being heated, heat transfer takes place by conduction. So velocity of the medium, that is plate, is zero. It is not moving at all. Now let us discuss the physical mechanism of heat transfer by conduction at micro level. So let me take one classical example of heating of rod. In the given figure, the rod is being heated at left hand with the help of flame, and its temperature is being recorded with the help of three thermometers, 1, 2 and 3. Now what is our general observation during this process? If you heat left hand of this rod, the right hand of this rod will automatically get heated after some time. That means heat has been transferred from left end of the solid rod to the right hand. And this heat transfer will take place unless the temperature of both the ends have become equal. Now, how this heat is being transferred from left hand to the right hand? Let us discuss. In order to understand what has happened at molecular level, let me explain this by playing this video first. Sorry, this video is not working. I have another video. Okay, so it is working now. Here, left hand of the rod is being heated. So let us say this rod is made up of so many number of molecules. Initially, when the rod is being heated, it is at its molecules are at room temperature. So their color is shown by white color. White color shows the normal temperature of the molecules. When the rod is being heated under the flame, its temperature will increase. That is, heat energy of the molecules will also increase, so as its kinetic energy. So now their color has been changed to red. That is, they are at higher heat energy level and temperature level. Now another video or another image is shown in the right hand side, where the flame is shown and different molecules are arranged in a proper sequence. This figure is nothing but expanded view of left hand side of the rod, that is at of this end. Now here initially these are the molecules on the left hand side and these are the molecules on the right hand side. Initially, when the rod is at atmospheric temperature, the temperature of all the molecules will be at room temperature, and this is shown by blue color. When the left hand of the rod is being heated, what happens? The molecules near to the flame will receive heat from the flame by virtue of temperature difference, and their temperature and hence heat energy and hence kinetic energy will increase. So they are converted into red color. That means their temperature and heat energy is increased. Now what happens when the molecules near to the flame receives heat from the flame? Their heat energy increases, so as the temperature, and because of this increase in temperature, their kinetic energy is also increasing. When their kinetic energy increases, they start vibrating about their mean position. Now, in solids, since molecules are closely packed, they cannot move away from their places. So, because of the increase in the kinetic energy, they come into a state of agitation and they start vibrating about their mean position. While doing so, they come into contact with the neighboring particles or molecules which are less energetic as compared to these molecules. And when they vibrate, they collide with each other, they come into contact with each other, molecular communication takes place between them, and by virtue of temperature difference, heat transfer takes place. So, second column of molecules will also become heated. They will also come into the state of agitation, will start vibrating, and will collide with the neighbor particles on the right hand side, will transfer some amount of heat to them. And third column of molecules or particles will also become heated. This process goes on and on from molecules in each column, and this process is continued till the heat is transferred to the molecules at the right hand of the rod. So now you can see. And this heat transfer from left hand or flame side to the right hand side will take place till the temperature of all the molecules become same. And the moment temperature of all the molecules on left hand side of the rod and right hand side of the rod become same, at that point of time there will be no heat transfer. Heat transfer will stop, because for a heat transfer to take place, temperature gradient is must. And this way, heat will be transferred by conduction in solids. Okay, let us move on to the next mode of heat transfer, that is convection. Now, convection is that mode of heat transfer by which heat transfer takes place between solid surface and adjacent fluid. That fluid can be liquid or gas. And what is the important point? That fluid is in motion. So I can say convection is the mode of heat transfer by which heat transfer takes place between solid surface and adjacent moving fluid. The moving fluid can be liquid or gas or powdery substance as well. Convection involves the combined effects of conduction and fluid motion. So in convection, some portion of conduction is also involved. And the highlight of this mode of heat transfer is medium through which heat transfer takes place by convection is moving. It will be in motion. Whereas in conduction, the medium through which heat transfer was taking place by conduction is not moving at all. So these are the medium by which heat transfer will take place between solid surface and fluids, between fluid mediums. The fluid medium combination can be liquid-liquid, liquid gas, liquid powdery medium or gaseous powdery medium. Now physical mechanism of heat transfer by convection mode. So how heat transfer takes place by convection? First, there will be transport of fluid or mass movement of fluid. This mass movement of fluid takes place due to buoyancy effect. I will explain that. And in second stage, mixing or circulation of fluid. Now examples of heat transfer by convection: chilling effect of cold wind on warm body. When a chilling, when a cold air wind is moving over your body, you feel chilling effect. Heating of room by stove. If you keep room, if you keep the burning stove at one corner of the room, what do you find? After some time, entire room gets heated up. So heat has been transferred from one corner of the room to the another corner by convection. Cooling of billets in the atmosphere. So let us discuss the physical mechanism of heat transfer by convection. So let us consider a hot surface. It is exposed to the cold air. Obviously, surface temperature of the plate is more than the temperature of the cold air. So all the cold air molecules are shown by green colors. That is, they are at temperatures less than the temperature of this plate. Now, how heat transfer will take place from this hot surface to the cold surface, because of which this hot surface will become cold. So, the cold air particle near to the hot surface, for example, here it is this, will come into contact with the hot surface, and heat transfer will take place from hot surface to this cold particle. So, it will become heated. The heated cold air particle is represented by red color. Now, when the cold air particle is become heated, its density decreases, it becomes lighter compared to the cold air particle, and it starts moving in the upward direction. Now, while moving, this hot air particle comes into contact with the cold air particle and comes into contact with it. And by virtue of temperature difference, it transfers some amount of heat to this cold air particle. So cold air particle will also become heated. And this way heat transfer takes place. So this way many cold air particles will come into contact with this surface, will become heated up, will be moving in the upward direction. While moving in the upward direction, will come into contact with many cold air particles, and by virtue of temperature difference, will transfer their heat to the cold air particles. So this upward movement of the fluid is nothing but transport or movement of the fluid, and contact of hot and cold air particle is called as diffusion or mixing of the fluid particles. Now, while these hot air particles are moving in the up direction, what happens? Some space is vacated by them. So, cold, heavier particles move in the downward direction, comes into contact with the hot surface, again becomes heated and moves in the upward direction. So this way heat is being transferred from hot surface to the cold air. And how long this transfer of heat will take place from hot surface to cold air? Till the temperatures of hot and cold air become same. The moment temperature of hot surface becomes equal to the temperature of cold air, heat transfer will stop immediately. Now here 2 points worth remembering or worth observing. Hot air particles are moving in the upward direction, cold air particles are moving in the downward direction. So transportation of fluid is taking place, and the fluid through which heat is being transferred is moving. Okay, so these are the two very important observations. So the downward movement of cold particles and upward movement of hot particles is called as convection current, and this will continue. This convection current, once set up, will be continued till there exists a temperature gradient between hot surface and cold surface, cold medium, cold air. The moment temperature gradient becomes zero, this convection current will stop. That is, there will be no downward movement of cold particles and upward movement of hot air particles. And this convection current setup is basically responsible for heat transfer in convection mode. So for heat transfer to take place by convection mode, first temperature difference must be there between hot surface and cold medium. This temperature difference causes density variation of the fluid particle. As we have seen, hot and cold particles, density variation is there. This density variation causes buoyancy forces to act on hot and cold air particles, which causes movement of fluid. So these are the three factors involved in heat transfer by convection mode of heat transfer. Now types of convection. As in the convection mode, fluid motion is involved. Fluid is moving. Now how that movement is created, how that fluid movement is affected, based upon that, two types of convections are there. One is called the free or natural convection, and second is called as forced convection. In free or natural convection, movement of fluid is caused or affected by buoyancy effect generated due to temperature difference. Whereas, and this buoyancy effect will cause upward movement of hot fluid particles, downward movement of cold fluid particles. In forced convection, movement of the fluid is affected by any external agency, such as fan, blower, pump or compressor. This fan, blower or compressor will cause fluid to move, and heat transfer in such a way is called as forced convection. Now, the point which is worth remembering here is that heat transfer rate by forced convection is much higher than the heat transfer rate by free convection for same temperature difference. Now the third mode of heat transfer is radiation. So no medium is required at all for radiation mode of heat transfer. And the physical mechanism by which heat transfer takes place by radiation mode is heat transfer takes place in the form of electromagnetic waves. And since electromagnetic waves can travel through the vacuum, So heat transfer by radiation mode will be more effective if there is no medium at all between two bodies. And the classical example of heat transfer by radiation is heat transfer between sun and the earth surface. Sun is the higher temperature body, earth is a cold temperature body, and it in between earth and sun and earth there exists vacuum space, even though we are receiving heat from the sun in the form of sun rays. So now let us take some different examples to understand more about modes of heat transfer. So in this example, there is a firewoods. There are firewoods burning. So if a stick is placed in the firewood flame, the heat transfer will take place from one end of the stick to the head side by conduction. If you place your heads on the upside of the flame, here fluid is coming into contact with the solid surface, so it will be by convection mode. And if you stay away from the flame so that you are not in direct contact with the flame, so heat transfer will take place by radiation. Similarly, heating of water in a pot. So heat transfer will take place by conduction from the pot through the handle to the head by conduction. To the upper side will be by convection. From this end of the pot to the water surface by convection, and from this heating coil to this pot, if it is not in contact with it, by radiation. This way we can understand the mode of heat transfer by conduction, convection and radiation. With this I come to an end of this lecture. So learning outcomes of this lecture will be, at the end of this lecture, learner will be able to identify and explain different modes of heat transfer like conduction, convection and radiation. You can easily identify the mode of heat transfer and you can explain also. Explain the physical mechanism of different modes and examples. So with this, I come to an end of this lecture. Thank you for your kind attention and passionate listening. Happy learning.